It's my pleasure to introduce our final speaker of the day, Sandy Vanderstoep. She is a good friend of NCN's and a former office mate. She is the project manager for PVI. I got to get it straight.
That's right.
Sure. And she is overseeing a really innovative initiative going on here at the Alliance Center. And we've talked a lot today about how important it is to focus on the people and the collaboration. But it's also interesting to think about all the outside of the box ways that your building can also help participate in your mission and in what it is that you are trying to do. So with that, take it away, Sandy.
Thank you very much. And I am really deeply honored to be here today. I must say I was a little confused until Saul and Paul and then Katie and Summer brought buildings to the forefront. Okay, I kind of wondered how I was going to lead into this because what we're doing here is really quite different. We are changing the way electricity operates in this building specifically. So what we are doing is we are creating a microgrid with alternating current and direct current. The direct current it comes from the solar panels on the roof, and it gets together, is the easiest way. It is combined with the alternating current to continue to provide uninterruptible electricity to the test bed, which is the Alliance suite, Alliance and NPN suite on this first floor. So Chelsea and I spent a little time yesterday walking this so that the people that are live streaming this will have an opportunity to see what it is we are doing. And in that process, Chelsea made a video that is about to make its debut, not only for all of you, but for me, okay?
Hi, Chelsea.
So,
Great to have you here for the tour. Would just love to have you be part of understanding what the direct current microgrid at the Alliance is all about. Come on, let's go on up to the roof and take a look at the solar panels. Hi, I just wanted to show you where one of the two sources of fuel come from for this direct current microgrid. The roof on the Alliance is now completely covered with solar panels that will generate about 24 kilowatt hours of fuel that will allow us to convert the Alliance suite to direct current for the plug loads and for the lighting in the suite. That will give us an energy comparison, an energy efficiency comparison that we think is really important. Let me show you where the electrical conduit runs all the way down through 6 stories in this building, so that we have to use what exists in the building in a retrofit setting. And so this large pipe is carrying the electrical charge from the solar panels all the way down to the equipment that is on the lower level. Using existing space becomes an extra challenge. If we did this in a new building, it'd be really pretty simple. In an existing building, we have to get really clever. The electrical current then is coming forward, both the alternating current and the direct current is coming forward and coming into a setting. One of the things we have to do is we have to make all of the electrons work with each other. So we need to convert the alternating current from the electrical grid using a rectifier. The rectifier changes alternating current to direct current. It is the entire function of this box to change alternating current from the grid to direct current so that it matches. Our direct current then comes into a series of disconnects so that you can always control when the flow of energy, just like you would in a normal electrical panel. And so these are disconnects that allow us to do an immediate shut-off if there is ever need to do that. For example, in the case of a fire in the building, you would want to be able to turn off all of your electricity, and these disconnects will take care of the direct current part of that. The action then is to bring the now direct current from the alternating current grid into the combiner box. In addition to that, the electrons from the solar array come into the combiner box, and they are all standardized so that they are synchronized with each other, and that takes place in this particular set of electrons. Then we have power sources which are going to drive the distributed energy resource here that fuel the next step. From the combiner box, the electrons come into the batteries, and from the batteries, the storage for the batteries, believe it or not, is really this small. And so we are looking at a tremendous amount of technology development that has reduced the size of batteries. We have 3 times as many batteries as we have solar power on the roof. From the batteries, the electrons flow into the distributed resource center, which is the DER, which is the brains of the system. The brains of the system make it possible for us to either shave our peak loads, which reduces our utility bill, to utilize direct current first, to utilize direct current only in the case of an outage. So we have resilience, we have an ability to move ahead. I understand there was an outage in Denver just yesterday that wiped out a whole area of Union Station. Had they been on some amount of direct current, they would be able to switch instantly and without manual intervention using software into the distributed energy. The main point here is really pretty simple. We mean to have the fuel that is generated, the fuel that generates direct current on site comes down here, is conditioned so that it goes through our system and then goes back up into our plug loads. That is, it will serve to be your charger for your cell phone, for your laptop, and into the lighting, in this case into the test bed, which is Suite 100, so that we will be able to keep lighting on, we'll be able to keep your cell phone charged, you will be able to keep your laptop working. You can take your chargers and you can toss them away. You are not going to need them anymore. All you need is one small USB cable in order to make it work. This is the future of clean energy. Clean energy is moving in this direction so that what we have is not just one building with a test bed. We are actually setting the foundation in a proof of concept that direct current, utilizing solar energy and then combining it with alternating current so that we have totally uninterruptible, adding batteries in, and truly batteries change everything in this process because it allows us to know that we have an uninterruptible source when we combine it with both the alternating current and with battery storage. Thanks so much. This is a great opportunity to share with you what's happening at the Alliance and why we are so excited about this project, which puts the Alliance at the forefront of the clean energy revolution in the world. Thank you. Thank you, and stay tuned as this project continues. Jenna, can you just, you're big, you're big.
Thank you, Chelsea. That was great. I appreciate that. It saved me a whole lot of explanation today, and it saved you a whole bunch of more PowerPoint slides. Okay. So in that process, then, well, you know, what we're really looking at is something that is, if you're building, Paul, Saul, Katie, Summer, everybody else who is owning a building or thinks they're about to have a long-term lease, wants to be on the front edge with your building, one of the directions that you want to contemplate and consider is using renewable energy, not just stopping with a PPA, a power purchase agreement, where you sell it back to Spokane Light and Electric, or whatever it's called in Spokane, but rather that you use that energy distributed on site. When you do that, you will be able to reduce not only the cost of your utility bill, because solar energy is free. Wind, for example, is also free. And those are direct current productions. There is no conversion then from direct current to alternating current to direct current to alternating current. When you pull out your charger for your computer, this young woman sitting back here who's not looking at me right now, who plugged in her computer next to me, okay? That charger is now warm, okay? That warmth is just loss of energy into the environment. It is electricity lost into perpetuity, okay? And what we are looking at as a possibility, and here we have a proof of concept. We are looking to do a turn on in this building, in the test bed, by 12/31/2017. And so I want you to stay tuned here. I want you to know that this is going to make a difference on a short-term base. This is not out into the future someplace. This is today. This is today's reality. So if you want your new building that you are about to acquire or license, or an old building, this building too was built in 1908. Okay? This is a 1908. Now, that means you have not only new market tax credits available to you, you have federal historic tax credits available to you, and in the state of Colorado, you have state historic tax credits available to you. Roughly two-thirds of the cost of our installation of direct current is going to be covered by tax credits. Two-thirds is going to be covered by tax credits. Renewable energy investment tax credits are 30%. Federal tax credits are 25%. State credits are 30%. And you just keep bundling all of these together in order to make that happen. And your nonprofit status, in most cases, works to your advantage rather than to a disadvantage. That's not exactly true for historic. You have to nest those. And those of you who are shaking your head know that we have shared an experience that is pretty traumatic. Okay? So why is direct current coming across now? Okay? Because we know Edison created this in the 1890s. Tesla won out, and indeed, alternating current has allowed not only the US, but two-thirds of the world to be electrified using alternating current. But when the resources become really either toxic or limited, you have to look at infinite sources for electricity. What do you think is going to happen when electric vehicles take over? What do you think the demand is going to be for electricity when electric vehicles, or even more, autonomous electric vehicles take over? Okay? It is going to be remarkable in terms of demand changes. And so what happens, the reason it happens now, I think, is a convergence in which the technology is available that makes solar and wind a viable direct current fuel. Storage is available mostly because of electric vehicles. Batteries have improved dramatically because of electric vehicles. And even the size of our batteries downstairs are remarkably small. It's remarkably small compared, there would be rooms that you would have to occupy. It's kind of like dialysis equipment. If you think about this, the shrinking of dialysis equipment compared, it would take rooms and rooms of equipment in order to run dialysis. It takes only something about the size of your 2 fists for your liver and to actually function extremely well, your kidneys to function extremely well as a dialysis component. Thanks to NASA, that miniaturization in electronics is well in place. So that as we then look at the convergence, not only of solar, but we look at storage and we look at electronics, suddenly direct current becomes a viable alternative. Now, no one would ever say that it is inexpensive to be in the lead. And the Alliance is way, way out in front of almost every other existing commercial building in terms of direct current usage. And so for those of you who like graphs, and I told you I was going to spare you a PowerPoint. So one of the things that happens when you have performance improvements and you have decreasing costs, okay? These costs are going down, okay? When you have performance improvements and decreasing costs, guess what you have? You have the beginning of a growth, and then you have exponential explosion, okay? Because as the costs come down and your performance goes up, everybody wants to have an iPhone 8, okay? Everybody wants to have the newest gadget out there where the price indeed is coming down. The iPhone 8 is not a good example of the price coming down. I realize that. But you get my point, that in the area of direct current, for example, we are seeing performance increase in batteries, we're seeing performance increase in solar and in electronics, and we're seeing the prices coming down. I mean, dramatically coming down. In the last quarter, the price of solar panels has dropped 18% in the last quarter, okay? So that if you're looking for a business case for this, there is one. But a business case is not going to be the compelling drive. What's going to be the compelling drive that is going to get us to exponential growth is going to be, this is truly where the market is going. You have an opportunity to take a look into the window of the future right now, right here today, and know that renewable energy is going to be the driving force of electricity, not just in the US, but in every place on this planet. Because if in Africa you do not have electricity at this point, are you really going to put in a $4 billion utility plant? Or are you going to put in some storage, some solar panels, and hook it all together with some electronics for 1/100th of the cost? Of course, you're going to the choice is going to be so apparent. You're going to leapfrog right over the alternating current because all of your electronics are native DC. They're all native DC. And so all that energy in that charger is the same as all the energy in these LED lights, okay? They're native DC. You have to have a ballast. You know your LED lights don't last nearly as long as your guarantee says they will. Why is that? It's because your ballast wears out. The thing that changes alternating to direct current every time you turn it on or off, that's the part that wears out. The light bulb itself is going to truly last for 30 years. Okay? So that as we look at the possibilities here, this becomes such a compelling position. So the project we have here at the Alliance is really a bridging project in which we are bridging from what we thought we could do to what we know we can do with a hands-on, here it is. This is not in the future, this is in today's world, and you do not have to be a big dreamer to see what the impact is going to be as direct current becomes absolutely the watchword in terms of where this is all going to go. So that my urging for you, especially for Urban Land Trust and for Northern California Community Loan Fund. Yeah, I almost had it right.
Well,
Community Loan Fund.
I'm always happy every time I get it.
Yeah, okay. Is to say, okay, or to take your building that has solar panels already in place. Those solar panels that are in place solve part of the problem. All you really have to do is figure out how to store some of that, hook it into AC, and drive it back into your building. Your cost will, in Denver, the cost per kilowatt hour is 9.6 cents on average across everything. In Saudi Arabia, right now, they are bidding solar at 1.6 cents per kilowatt hour. That is 7 times less than what you are paying. Okay? Tony Seba in Clean Disruption points out to us, and if you haven't read Clean Disruption or Rethink X, because this is a visionary who talks in real terms. When a performance of a new product, a cell phone, exceeds the performance of a landline by 10 times, disruption occurs. Okay? 10 times factor is the multiplier that drives you from, I'm going to continue to have my Kodak camera no matter what. Oh, but this one on my phone now works extremely well. Okay? When that 10 times factor hits, disruption occurs. Just ask the people who live in Rochester, New York, who no longer have jobs at Kodak. Okay? So that in this process, the disruption concept is one that when we hit this exponential growth, when we hit this, right now we're at a point right about here. Okay? It's proof of concept, we know it works. We need to commercialize it, we need to have it be repeatable and scalable and all of those things, and that's what we're working on. But this small project here at the Alliance is a leading light in moving toward that renewable energy, clean energy, direct current world. And so for that, I will be forever grateful for the opportunity to work on this project. For those of you who work around this project, who live with this project, who contribute to this project, thank you. Thank you ever so much. All of your thoughts, all of your feedback, all of your concerns, they help shape where we're going. But in truth, the path is really set in concrete at this point. But it's only set in concrete to the point of total flexibility, where we don't know where the utility companies are going to come in. If they're smart, Duke Electric, for example, is coming in with lots of embracing of the direct current approach. San Diego Gas and Electric is doing the same thing. I don't know if Spokane is. I know Seattle City Lights is, because we talked to them about the Bullet Building, and their solar panels and wind all go into a PPA, And so we hope that at some point they will use local on-site distribution as well. I suspect that we may have raised more questions than we have answers in this process. it is an introduction that I wanted to make to you all. Thank you all so much. And let's get on with the questions here.
All right. That was easy. That was quick.
So a lot of the IT infrastructure is DC capable, network switches, servers, for example. When we started doing the DuPont Center, DC really wasn't on the radar for us. We ended up doing a lot of 240 volt and using that for our energy savings. But a lot of that equipment is interchangeable, and a lot of that equipment runs 24 hours a day. Are there long-term plans to convert over the network infrastructure, servers, and switches to DC?
Well, one of the reasons we like the 240 or even the 480 on AC is that those typically run on variable drive frequency motors, and those are absolutely interchangeable. So that of your electricity in a commercial setting, 51% of it, on average, based on energy information administration, 51% of it goes to HVAC, okay? But 38% of it goes to lighting, plug loads, and other miscellaneous electrical equipment. So we made a decision here that we would use off-the-shelf alternatives on our test bed, okay? And even there, we struggle because DC to DC is not readily available. You know, we're still struggling with some of, Chris back there can tell you how we're still looking for the right plugins for some of the equipment and computers. But as we're working our way through that, what we realize is that using off the shelf will get us most of the way to the 38%. Phase two, phase two is going to be all addressed to HVAC. It's going to be addressed to fan-powered boxes. In our building, Chris, correct me if I'm wrong, in our building, seasonally, we are using 47% of our electrical load on fan-powered boxes.
It's a little bit, that is heating alone, actually. So if you incorporate cooling as well, it's even higher than that. Our heating load's about 40. The cooling load, I want to say, is around 15 to 20% of our total demand.
Yeah, thank you. And so we know we have to solve the mechanical side, but nobody is ready to provide us with anything except a VFD, okay? A variable frequency drive certainly can be applied, but we have a brand new York HVAC system on the roof. We really want to put that on a bench. We really want to bench it before we make that commitment, okay?
Good quickness. So we've had issues when we're trying to do innovative things in the building sector. Like our fire code officer is just a known jerk. And so did you have any like issues with code or like zoning or I don't even know the regulatory side of it?
It's a great question. Thank you very much. And it varies from really from metropolitan area to metropolitan area or group to group. Fortunately, we have really run into almost no limitations in terms of building requirements. Our electrical engineer, AE Design, did a very good job of greasing the skids going forward so that we had inspectors and reviewers that knew what was coming before it hit. The one thing we did run into was a new code for solar, which was going to reduce our ability to put solar on our roof because they wanted such big setbacks. And so it was really quite helpful to be able to go into the fire chief with a variance request and request of them that unless there was a safety problem or an access problem, could they give us a variance so we could go from 13 kilowatt hours to 26 kilowatt hours on the roof, which makes our test bed work really well. And it didn't hurt at all that I had the chief sustainability officer from the city of Denver sitting next to me at that meeting who said, and you know, Chief, Mayor Hancock really wants to support these innovative things. Of course, not at the loss of safety or access, but if you can find a way, it would be really good. And so when you have that culture behind you, it certainly is helpful. But one of the things we've done is to write a roadmap for you, okay? So that if you want to make a conversion, talk to us here at the Alliance, because we are here to provide you with a way to make that journey shorter, less expensive, and more effective, okay? And in that process, yes, we know how to get out of a PPA, okay? We know how to run a variance for additional solar. We know how to work with regional building to push it through, so that and if you need a team, we have a team that can make that happen, okay? We really do have a team.
Let me check time. All right, Maggie, you can take it. Really quick. So this building is a contributing building in the historic district, correct? So any insights that you can provide to some others who are dealing with historic districts with some of this?
Don't
work?
buy your doors too soon, okay? We've got a set of doors downstairs that didn't pass the IRS. It was actually an IRS merited review, and so we have a set of doors downstairs. In terms of historic buildings, I think what you need to realize is that there is a wealth of support out there in finding your way through it. What's difficult is to work a nonprofit through that, because you have to have a taxable entity that's involved, and the federal historic taxes cannot be transferred. You have to build the steps to get there. Okay, you have to build the steps. You know what? We'll help you get there. We've done it. We'll help you get there. We think historic buildings are way too important to not protect and to not innovate. Okay, innovation in a historic building, witness this one, it just provides a beautiful finished product. Okay.